Okay, so let's get into this. We've all, gotten pretty used to AI. It writes our emails, it makes images for us, answers quick questions. But what happens when that AI stops just being a tool you use and starts becoming this fully autonomous thing that actually takes initiative?
That is the core question for this deep dive. We're really trying to look over the horizon here into the world of what's called agentic AI. We need to understand how these systems go from being, reactive, just waiting for you to type something, to becoming true orchestrators, things that can plan, act, and adapt all on their own to hit a big goal.
And to really guide you through this, we have to start with the terms because they get thrown around so loosely. There are three big concepts we need to separate. First, the one we all know, conversational AI.
Right. Conversational AI is really just focused on interactions. So think chatbots, customer service bots, the thing that answers your HR questions internally. They're using LLMs, sure, and natural language processing to have a conversation, but their world is very, very small. They're basically, following a script.
Okay, and next up, the one that caused this whole explosion, generative AI.
Exactly. Generative AI is the creator. It's the engine. It's what makes the text, the code, the images, all of it. The LLM is the brain here. It can write you a perfect blueprint for a house down to the last screw. But that's it. It just writes. It stays in its little digital box.
Which brings us to the real reason we're here, agentic AI.
Agentic AI is the whole system. I mean, it absolutely uses that generative LLM as its brain, but its real power is orchestration, it's execution.
It's the manager on the job site.
That's a perfect analogy. The LLM writes the blueprint, but the agentic AI is the system that gets the permits, hires the crew, orders the wood, and crucially adjusts when it starts raining. It actually builds the house.
So the key difference is moving from just responding to a prompt to actually taking the initiative. Let's walk through that progression, that spectrum of autonomy, starting with the really simple stuff.
Yeah, so at the very bottom, you have what we call reactive agents
Yeah.
or reflex agents. They just operate on stimulus response.
If this, then that.
Pretty much. A phone rings, it plays a greeting, that's it. No memory, no context, and definitely no learning.
Then you move up a step to rule-based agents, which have been in big companies for, decades now.
Oh yeah, for a long time. They follow more complex branching logic. If a sales lead is from California, send it to Rep A. If they're a VP, send it to Rep B. They can handle sequences, but they're rigid. They're stuck with whatever rules a human programmed in. If something new happens, they just break.
Okay, and this is where it gets really interesting. The leap to true agentic AI. What is its superpower exactly?
The superpower is taking a really high-level, sometimes vague goal like revive our stale leads and figuring out the entire multi-step plan to do it all by itself. And this is the key. It doesn't just follow a set list. It plans, it acts, it watches what happens, and then it adjusts. In real time, no human needed. It takes initiative.
We have a great story that shows this perfectly. It's about an AI sales agent from a company called Warmly. What did it do that a simple rule-based system just couldn't?
Well, a traditional system would just, send email 1, then email 2, then email 3, and it's done. This agentic AI is different. It was watching for intent signals. And it noticed a prospect, looked at the sales rep's calendar link, not once, but twice, and then didn't book a meeting.
Ah, so that's a piece of context a normal system would totally miss.
Completely. The agent saw that as a problem to be solved right now.
Huh.
So it came up with a little two-part plan on its own. First, it sent a personalized reminder email. And second, if there was still no reply after 24 hours, it switched channels completely and sent a personalized message on LinkedIn.
Wow. So it analyzed the situation, came up with a multi-channel plan, and then executed it across 2 different platforms.
That's autonomy.
That is amazing. So the difference between following a recipe and actually knowing how to cook. So to do that, the architecture underneath has to be really solid. Let's get into that cognitive loop, the think, act, observe loop.
Yeah, this loop is so cool because it basically mirrors how humans solve problems. You look at a situation, you make a plan, you try it, and you see if it worked. The AI does that with 5 key parts, just over and over again.
And it all has to start with how the AI sees the world, right? The perception module.
Exactly. Think of it as the agent's senses. Its eyes, its ears, it's pulling in data from everywhere. APIs, databases, sensors, even text and images using things like RAG. That's how the Warmly agent saw those calendar clicks.
And once it has that data, it moves to the brain, the cognitive module.
This is where the LLM really shines. The module's most important job is something called task decomposition. It takes a huge goal, like build a web app, and breaks it into small, doable steps.
Step 1, set up the server. Step
Yeah.
2, write the login code.
Exactly. It makes a plan of attack.
But for a big project, it needs to remember more than just what it's doing right now. This brings us to memory, and this is a really important distinction for you to get.
It's absolutely critical. You need two kinds of memory. First, there's short-term memory. Think of it like a notepad. It keeps track of the current task, the context. It makes sure step 3 knows what happens in step 2.
But it gets wiped clean after the job is done.
Right. It's temporary. That's why you need long-term memory. This is the AI's library. It's persistent knowledge base. This is where things like vector stores come in. And don't worry about the jargon. Just think of it as a way for the AI to search for information by meaning, not just keywords. It remembers what worked 6 months ago.
Okay, so the plan is made, it has its memory, now it has to actually do something, the action module.
Yep, this is the execution part. This is where it translates the plan into an actual outcome. It could be making an API call to Salesforce, or writing and running some code, or even moving a robot arm in a factory.
And then, to close the loop, it has to learn. An agent that doesn't learn isn't really autonomous.
That's the reflection or the feedback loop. The agent looks at the results of its actions. Did the code work? Did the sale close? And it uses that information to update its approach for next time. It's constantly getting smarter.
So this isn't just theory anymore. These agents are out there, in the wild, doing really high-stakes work. Let's talk about 3 surprising examples, starting with something that sounds like pure science fiction: autonomous software engineering.
It really did until Devin from Cognition showed up. People are calling it the world's first fully agentic AI software engineer, and it does way more than just complete your code.
What does taking over really look like in that context?
I mean, you give it a goal like build me a web app with user logins, and it literally does the whole thing. It sets up the cloud server, it installs what it needs, writes all the code, puts it on GitHub.
And if there's a bug?
It doesn't just stop and wait for a person. It reads the error message, figures out what went wrong, changes the code, and tries again, all by itself.
And we saw just how fast this can be with that story about 2 different agents working together.
That was incredible. You had OpenAI's operator and Replit AI agent basically collaborating. They shared credentials, worked on different parts of the project, and built a whole working app in 90 minutes.
90 minutes. Wow. Okay, moving from engineering over to the sales and marketing side, we're seeing agents act as actual strategists.
Yeah, this is a great example. These agents are like super-powered marketing ops specialists. An agent can identify your ideal customer, which is hard enough, but then it watches in real time for signals from like 10 or more different data sources: your website, LinkedIn job changes, financial news.
Which is just a flood of data that no human team could possibly keep up with.
It's impossible.
Yeah.
And when a lead shows enough intent, maybe they visit the pricing page 3 times, the agent doesn't just fire off a generic email. It orchestrates a whole response.
So it's not just sending an email, it's what?
It's sending a Slack alert to the right sales rep, updating the CRM, and triggering the perfect marketing campaign for that specific person based on their exact behavior. It's always on, always adapting.
And finally, let's go from the digital world to the physical world, the dark factory.
The dark factory is kind of the ultimate vision of physical autonomy. A great example is predictive maintenance. In a big factory, an AI can analyze data like tiny metal particles in oil to predict exactly when a machine part is going to fail.
And the value there is all about timing.
It's huge. You can schedule the repair for just before it breaks, so you don't have a catastrophic failure, which costs a fortune, but you also don't waste money replacing a part that's still perfectly good.
And the ultimate example of this is that FANUC factory, right, near Mount Fuji.
That's the one. It's been running since 2001. It's a factory where robots build other robots, 247, with no lights, no heat, because there are no people inside. It just shows you how mature this technology already is in some sectors.
Okay, so it's clear this autonomy drives incredible efficiency. But the second you give an AI that much power and access, the security and ethical alarms start going off. Let's talk about that security dilemma. What is this new attack surface?
The whole model just flips. These AI agents aren't just users, they are high-privilege identities. They have API keys and tokens that let them touch tons of sensitive systems. This creates what security experts call a non-deterministic attack surface.
Non-deterministic. What does that mean for you listening at home?
It means you can't predict what the agent is going to do next because it's constantly learning and changing its own behavior. You can't just write a simple rule saying, Agent A is only allowed to do these 3 things. Tomorrow, it might invent a 4th thing to do to achieve its goal.
And what are the big technical threats that exploit that unpredictability?
Well, the first is prompt injection. This is where an attacker messes with the data the agent is seeing in the prompt to trick it into doing something bad. You could, for example, fool a financial agent into pulling up account details for the wrong user just by crafting a malicious input.
And the second threat sounds even worse.
It is. It's identity and token compromise. These agents use API keys that have really broad permissions. They need them to do their job across all these different systems. If an attacker steals one of those high-privileged tokens, they basically have the keys to the entire kingdom. The blast radius is so much bigger than just stealing one person's password.
But if the agent is always changing and we can't use fixed rules, how on earth do you secure it? It feels like you're always one step behind.
That's the challenge. And the answer is you have to stop trying to secure the rules and start monitoring the behavior. Companies have to use behavioral analytics to figure out what's normal for an agent. How much data does it usually access? Which systems does it normally talk to? Then, if it suddenly starts trying to access 10 times more data or pings a database it's never touched before, that's a massive red flag. It all comes down to zero trust. You never, ever inherently trust the agent.
Beyond the tech security, there's the human side, the workforce impact. The sources we looked at paint a pretty stark picture, especially in industries like oil and gas.
They really do. I mean, look at that oil industry example. When oil prices crash, companies automated a lot of jobs at the wells. A site that used to need 20 people could now run with 5, and here's the really crucial part. When prices went back up, most of those jobs didn't come back. Automation can be a one-way door.
So the ethical question isn't if it happens, but how a company handles it. And we saw two very different approaches.
Yeah, on the one hand, you have a company like Rio Tinto. When they brought in autonomous trucks, they made a public promise to find new jobs with retraining for every single one of the 100 drivers who were displaced. And they did it.
Which is a very sharp contrast to what happened with Westpac Bank.
Exactly. They got so much negative press for announcing big layoffs at the exact same time they were advertising for 2,000 new digital natives. The message is pretty clear. If you're going to automate, you have a responsibility to invest in reskilling the people whose expertise you're turning into code. So if we pull this all together, I think the key takeaway is that agentic AI is this pivotal moment. It's what turns the LLM from being just a really smart encyclopedia into a true decision maker, an actor in the real world.
Right, the shift from thinking to actually autonomously doing. And that requires us to completely rethink governance because these things are designed to just keep learning and improving on their own. Which leads us to our final provocative thought for you. The EU AI Act says that by August 2026, member countries have to set up these special AI regulatory sandboxes to test high-risk autonomous systems. So here's the question. If an autonomous agent is capable of continuous learning, of recursive self-improvement, is the real challenge how fast we can build them? Or is it whether our human regulators, our governance frameworks, can learn fast enough inside those sandboxes to actually keep up with the intelligence they're supposed to be watching?
It really gets to the heart of the problem, doesn't it? The speed of governance versus the speed of technology. Something to think about as these agents start making more decisions for us.
That's all the time we have for this deep dive. We'll see you next time.